Let's take a look at how you can use cluster info to demonstrate taints and tolerations in Kubernetes. So right now we're at the nodes view, and before we start this demo, let's go ahead and make sure that we're looking at micropods, because we only want to look at the pods as a whole, not the individual pods. So we want to be able to see as many pods on the screen as possible. So let's go ahead and deploy some basic workloads onto our cluster. So the default scheduler is load balancing the workloads across the different nodes because it has no other direction on what to do. The goal in this demo is to select one of these nodes and send all of a particular type of deployment to that node, and also make sure that other deployments don't end up on that node. So let's go ahead and let's pick this node, for example, as the node that we're going to work with. So let's go ahead and save the name of that node. Okay, and then we're going to add a color to that node to help us keep track of the fact that the node is the one we're going to be working with. So in this case, we've colored this node green, and we have some green workloads. So the first thing we want to do is have all the green workloads end up on this green node. And so we've started the process by adding a label to the node that says allow process, and the value is GPU. So the first step we're going to do is we're going to add that as a node selector to all the green pods. So if we look at the current definition of those pods, we can see that the node selector only specifies Linux as the operating system. So now we're going to apply a node selector to that deployment, and basically this will designate that node as the only valid node that those pods can be scheduled on. And as if we can see, all the previous pods have been deleted, and then the new ones have been rescheduled. Because if we look at that definition now, we can see the node selector includes that label that we added to the node previously. And that's great. So we've achieved half of our goal, is making sure that all the green pods are scheduled on the green node, but now we want to kick out all of the other non-green pods off this node so that there's plenty of room left over for the green pods to scale should they need to do so. So the best way to do that is to put a taint on the node. So let's go ahead and put a taint on that node. Okay, we do that with the simple Kubernetes taint command, and as you can see, all of the current pods are kicked off of that node. Now, the other pods are easily rescheduled on other nodes because they have no restrictions to them. However, these pods can't be rescheduled because in this case the green pods are all now pending state because they didn't match the taint of the node we want them to be on, and they didn't match the node selector of the other two nodes, so they have nowhere to go. So the scheduler can't schedule them anywhere. As we can confirm, there is a taint now on this node. So then the final step is to have these pods tolerate that taint. And we do that by simply adding a toleration section to the definition of those pods, and now they're able to tolerate the taint of that node, and the node selector makes sure that they're only scheduled on that node. So now this is a way of using cluster info to demonstrate taints, tolerations, and node selectors.